Hey, everybody, you're listening to Angelneers. Angelneers is a Silicon Valley community that brings startup builders and experienced operators together to share key insights on how to build and scale startups. I'm your host, Oleg Kujikov, and our guest today is Aaron Nathan, a co-founder and CEO of Point One Navigation that's solving one of the key unsolved problems for intelligent machines, determining position with a high degree of precision and confidence in all situations. They do this with a unique combination of computer vision, satellite navigation, and sensor fusion. Today, we're talking with Aaron about how all of that combined is solving the transportation problems of the future. But before we get into that, Aaron, welcome to the show.
Hey, Oleg. Thanks for having me.
Yeah, let's get to know you a little bit. Tell us about yourself. How'd you get started in technology?
Yeah, I mean, I've been obsessed with robotics really ever since I was a kid, and I made it kind of a mission to go to Cornell and work on the robotics soccer team. I did that, and then while I was in university, the Department of Defense announced this project to go and build a car that could go drive 100 miles through the desert with no driver. And that was called the DARPA Grand Challenge. And I also am a big car person. And so to join robotics and cars into one project was kind of one of the most exciting things that could possibly happen. So immediately I started a team at Cornell to actually go and compete in the Grand Challenge. And that basically started my career and frankly, many others' careers that are in the autonomous driving space today. We went from there to basically building not one, but two vehicles. We were one of the six that actually finished the actual challenge itself and really just got to see all the different problems that go into building such complicated robotic machines. And location was kind of one of the most fascinating. And really, that was where I focused my career professionally on since I graduated college.
Really interesting. I almost remember that like being in the news. I think I was, in high school at the time. But can you expand on the DARPA Grand Challenge? Like, what was it? And talk more about the solution you put together and what technologies you worked with.
Yeah, absolutely. I mean, so the Grand Challenge at a very high level, the idea was to take a vehicle and have it originally drive first through the desert for about 100 miles with no driver. And so this is rough off-road terrain. And basically all you had were a series of kind of GPS waypoints, and you had to make the car be able to navigate, rocks, boulders, cliffs, all kinds of crazy things. And you have to understand that like back then, like a whole server had less processing power than your iPhone. And so it was, quite a challenging thing to do. And the first year, I think the best team was Carnegie Mellon, and they made it 7 miles. And so, it was a incredibly ambitious thing to do. Now, the second time they did it, it was the same idea. It was, go drive 100 miles in the desert, and actually a bunch of teams finished. And so this was incredible progress to see. So much so that then the third time, DARPA, the agency that was running this competition, they said, okay, we're going to raise the stakes. We're going to now basically make a mock city. So they took an old army base and they hired like a whole bunch of stunt drivers to simulate traffic. So you had 30 Ford Tauruses driving around. And they basically had, I think it was 12 vehicles that went through all these qualifications, and they just drove around simulating kind of like an Uber-like service, picking up, virtual people. It wasn't actual people. But the cars would have to go and navigate stop signs and, basically not run into each other, not run into the other car traffic, the buildings. Incredibly difficult to do. We were one of the 6 teams that actually managed to do that for 6 hours continuously with no human interaction, no one in the driver's seat. And this was, 14 years ago. So this was honestly the genesis point for many companies in the autonomous driving space. The people who went on to build the Google self-driving car that's now Waymo, Cruise, the guys at Aurora. I mean, they're all from the original DARPA Urban Challenge days. So it's kind of amazing to see how much has really stemmed from that one event.
Really cool. Really cool. So curious to learn more about like what kind of technologies did you use in that challenge that you'd later bring to your current venture to Point One Nav? Because like these cars had a challenge, right, of navigating 100 miles of desert, but the solution you picked, you could, if I knew exactly what the road was like, I could just tell the car, well, I could program it, right? Hey, here, for the next 100 miles, you're going to drive a mile, turn right, go straight for 100 yards and turn. But you have to come up with a way. That's not going to work, obviously. That's a silly solution. What kind of solution was in your car that kind of led into Point One Nav?
Yeah, no, for sure. I mean, and to be honest, your proposed solution is not all that different than how it actually works. The hard part is knowing where you are and where you want to go. And ultimately, what Point One does is it solves at least that first problem of knowing where you are. Because if you have a map and you kind of can understand whether it's a road or a dirt trail, it kind of doesn't matter. What you're really trying to do is have the car, steer so it stays on the road. And ultimately, what Point One does, and what frankly most self-driving car companies are doing, is they just have a map that's like incredibly accurate. We're talking down to like centimeter level, and then they have a way of kind of putting the car in that map to also centimeter level. And so instead of like when you and I drive, we're constantly using our brains and our eyes to understand, oh, I want to stay, with, the yellow line on the left. What's actually happening with a lot of these autonomous vehicles is they use this very high resolution map to understand that, okay, the vehicle itself is driving where it's supposed to. And that's something that, that perception problem of understanding, the yellow line on the left and the white line on the right means that I'm where I should be. It can be solved in a way that is more reliable for machines. And so pretty much every large scale autonomous driving company is building things that way. And so this is I think a really important thing that maybe not be obvious to people who haven't gone and built autonomous vehicles, but the reliance on these maps is really, really important. And it's one of the key things that actually makes us able to even have something that is approaching autonomous driving. Because I mean, to date, like there is no such thing as a fully autonomous car. Like, we're still quite a ways away from that. There are certainly ones that partially exist, but there are still a lot of limitations in terms of what they can do. And solving these problems of knowing where you are and making that very reliable, that's one of the key ones that has to get solved to actually enable fully autonomous vehicles.
So this is like a key problem that we got to figure out how to solve before the dream of an autonomous vehicle is even possible. So that's what we're talking about today. Let's do it. There's several technologies that you can use to identify like geographic position, both indoors and outdoors. The one, you and I probably know the best, or the listener probably knows the best, is just GPS, Global Positioning System. But there's other systems too. For example, Enhanced Observed Time Difference or Enhanced GPS, and also Wi-Fi and Bluetooth can do some of this too these days. So let's start our conversation with like a brief overview. Can you tell me like what the state of location technologies is like today?
Yeah, for sure. So like all of the signals that you talked about, whether it's GPS or some of these enhancements or Wi-Fi or Bluetooth, they're all similar in that they're radio signals. So that means is that they're signals that can go through objects and still be received. Now, the difference is that, GPS is coming from the satellite in outer space versus, Wi-Fi and Bluetooth are kind of little, radios that are on the other side of your living room wall. And so the power levels of what you see on GPS are incredibly low compared to what you see on like things like Wi-Fi and Bluetooth. But the difference is that GPS was built from day one for telling you where you are, for navigation. And the way that, at a very, very high level that works is that those signals can ultimately tell you the distance from you to the satellite in space. And then kind of using more or less fancy geometry, you can triangulate that down to, a pretty accurate position. Now, with things like Wi-Fi and Bluetooth, I think most people probably don't realize this, but actually, when you use your phone, like in a city, your phone is actually smart enough to start to use those signals for location as well. And actually, the way that works is that sometimes, the phone companies or other independent companies will actually build maps of like all the hotspots that, let's say, are in New York City, and then be able to say, just based on like what the relative signal strength of the Wi-Fi that it sees, it can actually come up with a better solution than the GPS signal that's totally blocked by some tall buildings. And so this is actually kind of, I would say, one way of doing the thing that Point One does, which is called sensor fusion. And at its heart, the whole idea is that you can kind of use the best sensor for that particular circumstance that you find yourself in. So like if I'm driving on a big open highway, like GPS is going to be great because I can see all the satellites in the sky, and that signal was designed for navigation. But in downtown Manhattan, there's tall buildings everywhere. I'm lucky if I can see any sky. And so there, really, your phone is automatically smart enough to say, well, I'm going to start using like this, Wi-Fi map-based technique. And there's companies that now have taken Bluetooth and actually can do stuff like tell you where you are in a store based on which of these Bluetooth, they call them beacons, are transmitting. And so, there's a lot of these kind of like piecemeal technologies. And when you look at it, none of these are comprehensive. And so the real problem is, how do you build a system that does the sensor fusion in a way that's like working in all situations that we care about? And this is really kind of Point One's goal, is to make it so that our users don't have to think about, do I use GPS? Do I use Wi-Fi? Do I use inertial navigation, or all these other kind of SLAM-based navigations? It just kind of works. And that's the core idea.
Can you talk about the accuracy of some of these location technologies and maybe like compare them based on use case?
Yeah, for sure. GPS originally was accurate to about, let's say 10 meters after, the government basically said that we're going to turn off this thing called selective availability. So in the early days, like all the way in the 2000s, there was worry that, if we enable precise location, people are going to build all kinds of, bad weapons and things like this. And that didn't happen. So it was actually earlier than that. I think it was Clinton that signed the order that basically said that, okay, we're not going to scramble GPS anymore. So since then, GPS has gotten better and better. And, your phone today will do about, let's say, 5 meters of GPS accuracy in ideal circumstances. The other methods like EOTD and eGPS, eGPS can get you a lot better, but it's really more optimized for getting you GPS quickly. So you open Google Maps and you kind of want to see that blue dot instantly. That's a lot of the AGPS type of functionality. And when you look at Wi-Fi and Bluetooth, it really actually, those depend on the density of basically the stations that are out there. So in Manhattan, where there's probably, I don't even know how many thousands of Wi-Fi hotspots. It's actually pretty good. Like you can get easily down to 10, 20 meters, which is plenty for your Uber driver to find you and pick you up. But none of those technologies get close to the level that you need for something like autonomous driving, where I need to know not just what lane I'm in on the road, but where I am within the lane. And so ultimately, I kind of like to think of location kind of like TV. If you ever watch an old show that they've recorded, it kind of blows your mind, especially like sports, where it's like, I think that's the ball, but it's like standard definition television is so bad. That's kind of where location is today. And what companies are working on is really enabling high definition location. And to us, that's something that's, sub meter. And specifically, in the centimeter kind of range. And what you can do with that is just amazing.
How accurate do we need to be for autonomous driving? So, like current technologies, you're saying accurate to 5 meters. How accurate does this need to get for like autonomous driving to be, possible?
Yeah, so I mean, our belief is the answer is, I mean, roughly speaking, 10 centimeters is where you need to be. It's like kind of the rough width of a tire. And I would say if you look at how accurately an average human driver can put their car, it's about 10 centimeters. And, at the end of the day, what's even more important for autonomous driving is not just that it's accurate, but that it's reliable. Because if it's only accurate, let's say 50% of the time, you can't just be like crashing into things the other 50% of the time. So it's a very important thing that when we talk about accuracy, it's always like in a statistical sense. So like 95% of a drive, that it's always below 10 centimeters of error. That's kind of, it's always tied to that kind of statistical availability. And this is just very common in all robotic systems, but is very easy to understand, I think, for an autonomous vehicle.
Okay, so before we get to point one, what are some of the main applications of location-based technology today?
Absolutely. I mean, location is one of these things that is used in ways that are obvious and not obvious. So the obvious ones are when we use our phones and we request a Lyft or an Uber, it's obviously sending your location to some server, and then it's using the location of all of its drivers to basically match you together. That's used for not just riders and passengers, but it's also used for delivery of goods. So whether you're a logistics company and you're trying to make it so that your driver can actually find the doorstep that they're trying to take that package to, or if you as the user are curious, hey, where's my FedEx parcel? So those are some of the examples that are more obvious. I think less obvious things that we've started to see in the market. Companies like to have location-dependent experiences. So let me give you an actual example. There's an explosion of like these scooter companies that are putting their scooters all throughout cities, and you want these scooters to be safe. And so on sidewalks, generally you want them to be going slower than if someone's riding the scooter like in the bike lane. And so people are actually using location technology to remotely enforce those speed limits on the scooter. So they just kind of have a map that tells them where the sidewalks are, and they say, okay, if the scooter is on the sidewalk, it can only go 5 miles an hour. And that's like a very simple way to make it so that ultimately people are operating these things safely, and then the companies that are running the scooters don't run into problems with the municipalities. That's maybe one unobvious example. One of the others that I think is kind of fun is even in today's vehicles, there's certain degrees of autonomy, as people call it, really more advanced driver assistance. Using location allows these systems to kind of learn about their environment and become more intelligent, even in a coarse manner. So some of the more advanced systems, like those from GM and some of the other newer car companies, they're using location to augment their other sensors, their cameras and LiDARs and things like this, to know what to expect. So like, you can know that the road is about to turn sharply and I need to slow down way before your camera can see that the road is about to turn, or it can know that that thing on the side is actually an off ramp and not another lane. So it shouldn't, merge into that to get around traffic. I mean, these sound silly, but these are actually like real applications that people are working on. And that's just the beginning. What we're going to see very soon is when you start to look at gaming, and especially in the AR side, people using location to make it so that you don't just have like, oh, here's a Pokemon in some virtual environment, but multiple people can actually see like the same virtual character on like a consistently rendered plane. And what that means in, I guess, English is that like the experience really feels magical, right? Because it looks like undistinguishable from reality, because all the, what's in front of what and all these things are operating correctly in real time. And you can only do that if you really have accurate and reliable location. So the diversity of those use cases, I think, is what's so exciting about the space.
Yeah, and I'm sure you could like keep going, right?
Yeah.
But we only have so much time. Cool. Well, let's get to point one. Give us the elevator pitch. How do you explain it in 30, 60 seconds or less?
Yeah. Point one is the API for precise location. So what we're doing is making it so developers can very easily get to centimeter location on anything that moves in the real world. And that's really what point one is. You don't need to think about, GPS and all these low level sensors. It's basically an API that just tells you where your things are. And that ultimately unlocks all the things that we just talked about in terms of use cases. It makes it easier for people to build on top of us. We like to think of ourselves as kind of like behind the curtain. We're enabling people to build magical experiences, but we may not be the company that people see directly. So consumers never really interact with point one. It's really, we're a developer first company.
Are you a developer? My question is, what was the aha moment that led to kind of creating the company? I'm wondering, were you a developer and you had a need for a location technology that's in the format of an API that I can just get location via? What's the story of starting the company?
Yeah, basically I skipped over in my background. After the Urban Challenges, I ran the robotics lab at Cornell for a short period of time. And I helped a whole bunch of students work on all kinds of projects in robotics. And I saw that the problem that everyone ran into is that as soon as you took the robot out of the lab, it was very, very difficult to do anything because you just didn't have a grid to operate over. Meaning, if you can talk about where the robot is or where the obstacle is or where its goal is, it becomes very easy. Basically, it's almost like a computer game, right? But if you don't have that very simple construct of location, these relatively simple use cases become impossible. And so I think the aha moment, frankly, was we always knew that this was a big problem, but the real issue was that it was very expensive to solve. So back in the Urban Challenge, we probably spent somewhere between $50,000 and $100,000 to build the system that told us where we were. And obviously that doesn't scale to almost any use case. And so what we saw, though, was that the price of a lot of the different parts to build the system had come down by orders of magnitude, and that a lot of the compute that you need to actually run these algorithms had also become very inexpensive. And a lot of this, frankly, was driven by what we were seeing with smartphones. And so when we looked at this, we said, hey, listen, that system that cost us $50,000 to $100,000 to build 15 years ago, we can now build for, less than $100. And so that really was wow, now it makes sense to put this on every scooter or every car or every, frankly, dog collar. And so it's amazing what happens when all of a sudden the combination of the technology readiness and the price of the components coming down, it really changes what's possible.
And hey, scooters are a lot easier to replace than dogs. So let's get those location services in the collars first.
I agree.
All right. Who are the people behind point one? Who have you kind of gone, who have you brought around you to go on this journey with you?
As you can imagine, the first thing that we had to solve was to take a bunch of really, really hard algorithmic problems, math problems, these kinds of things, and find the best people to solve them. And I was really lucky to have folks that I'd worked with both in the university days and also in some of my earlier startups and the DARPA challenge. And so I basically went back to them and said, hey, listen, this is the opportunity. There's something amazing here. We can go and do some of the things that we'd been working on and now do it at commercial scale, which is really exciting. So yeah, one of our first people to join the company was Mike Kurtzel, and he's basically responsible for building all of our what we call like back-end services. So you can imagine as an API company, that's all the stuff that runs in the cloud, all the servers that kind of do all the processing, and that's been a huge benefit for us because, frankly, it's one of the places that we really excel at when you compare it to our competitors. After that, I brought on Ryan Doherty, who is basically in charge of our sensor fusion algorithms. So he's leading a team now that is figuring out that, how do we work with this sensor or that sensor, and when do we do that, and basically building an algorithm that can automatically do that and use the right thing for the right time and the right environment. And then lastly, Karen Lineweber is in charge of our computer vision. So this is basically when we look at how do we take the world in places where like that GPS signal is not coming in. One of Point One's core strategies is to use cameras. And so that camera data is very, very difficult to work with. And we've been building algorithms to basically incorporate that into this sensor fusion package for the last 5 years. And it's we've done some really amazing things, enabled like navigation in like underground parking garages where obviously you have no GPS at all. And it's amazing to see when you take all of those together, the technology really can work anywhere. Since then, obviously we've added folks on the sales team. Mike Coletta leads my sales organization. He came from selling in automotive for over a decade. He was at Ford and a company called Laird that builds like antennas and really helped build the business side of Point One. And so I think that we've come together now with something that's an incredible technology and a team that knows how to bring it to market. And that's, I think, two of the most important ingredients in building a business.
Let's look under the hood. Talk about your tech stack and what kind of important choices you had to make early on.
Our technology stack is admittedly very complex. And I think this is true of a lot of API companies, that the whole value of what you do is that you make it so other developers don't have to build all the complexity that you did. They could just kind of call something and take advantage of that. So we've built the vast majority of our system actually in a very old language called C++. And, it's something that we've ultimately, because part of keeping things so that it can work in mass market is they have to be very efficient. And that means that we can use smaller processors, lower cost, lower power. And that's actually worked out really well for us. So we just made an announcement like a few months ago of a hardware module with one of our very close partners. And it's amazing because the whole thing fits in like a package that's smaller than the size of a quarter. That wouldn't have been possible if we had chosen a different, easier to use, let's say, language. Now, obviously, like for cloud services and things like that, we are using more modern things. And so we're using languages, like Go, a lot of Node, a lot of actually Java as well. And it's built on a lot of, I would say, modern cloud microservices architecture. We use Kubernetes extensively. And I didn't even talk about part of what makes our technology work is that we have roughly about 1,000 of these kind of sensors that are permanently installed across the United States. And we use those to help actually correct the GPS signal. So I kind of told you before, GPS is only accurate to 5 meters. But it turns out that if you can figure out like what happened to the signal from the time it left the satellite to the time it arrived on Earth, you can kind of like cancel out for that. Think about it like reading glasses for your GPS receiver. And this is part of what our product does is that it uses these 1,000 sensors across the US to understand, okay, like what's wrong with the signals here in San Francisco or in New York or wherever you might be. And then your algorithms can basically remove that error. They literally just subtract it off of what they see from the live satellites. And this allows us to basically get like 100x improvement. So quite literally, you can get down to like 5 centimeters of accuracy from GPS alone. Which, I mean, just think about it. It's like the size of a baseball from something that's orbiting in space, 25,000 kilometers. It's just absolutely mind blowing. Even, we built a lot of this technology, and I still can't believe it. So, we see there's so many pieces to what we have to build, and I think this is part of the uniqueness of our team. I mean, the whole company is 30 people, and we've built all those things I just said with this incredibly small but very hardworking team.
Can you talk about two questions? One, I'm curious, like what kind of sensors you have installed that help you with the reading glasses adjustment, we'll call it. And second question is, sensor fusion. Can you just talk about sensor fusion? We kind of mentioned it at the top. It sounds complex. I kind of wish I'd asked it before I asked about the tech stack. What is sensor fusion? Let's start there, and then you can tell me what kind of sensors you got all over the United States. And if
well, don't be worried. Let's start with sensor fusion. So, I mean, at a high level, sensor fusion is this entire discipline to understand if we have, a camera, let's say, that's telling us one thing about location, and then we have a GPS that's telling us another thing about location. And then we may also have something called an IMU that measures, your rate of rotation and accelerations. May also tell you something about your location or even just how you move. How do you combine like this incomplete information that you have from all these different sensors and do that in a way that you can say is accurate or robust or any metric really? And, in a very naive way, what people used to do was to say, okay, well, I'm outside, use GPS. Okay, now I went inside, use the camera or use, some other Bluetooth sensor. And it's just like this hard switch. The problem with that is that, your position is going to jump all over the place when you switch between those systems. And so we use a whole lot of math to basically understand how you can basically learn which sensor is the right one to trust, and then do that in a not like binary, like on or off way, but actually blend them in a way that is statistically correct. And so what do I mean by this? Your GPS, let's say as an example, just may be really confident about like your east-west direction, but like really not sure about your north-south direction because of, a building that's blocking you there. But you may have another sensor that's telling you, hey, I know that, there's no way that you've moved in the north-south direction. And so what our algorithms are able to do is basically use that information to kind of fill in the blanks. And it can use that, for instance, it knows a car not only has information about GPS and IMUs and all these other sensors, but also knows that like generally a car is not drifting sideways, right? It can basically move forward and move with the wheels. And so we have an algorithm that can take all of those kind of like constraints and then effectively solve for what is the most likely combination of all this data, and then distill it down into like, okay, what's the position? And not only just tell you what the position is, but then tell you how confident it is. Because if I have two sensors that both think they're confident but have different answers, then I want to tell my user that, hey, there's some disagreement here, so I'm going to say that I'm not so sure about where I am. And so sensor fusion is all of that. It's combining sensors, saying how confident you are in that combination, and then being able to kind of like switch around the weights of all those different sensors in a way that's actually intelligent. It's incredibly hard to do. And that's why we tried to make this an API that developers shouldn't need to know how to do that to build a lawnmower robot, as an example.
Awesome. Well, thank you for breaking it down. Sensor fusion. Wow. Talk about some milestones you've achieved along your journey so far. What are some of maybe like the 2 or 3 key milestones that you've achieved?
Yeah. So I would say like our first milestone was getting these like, 1,000 reference sensors across the US. And that was one of those things that when we started the company, everyone kind of looked at us like we were crazy because, I mean, quite literally, we have like 1,000 leases for maybe like 2 by 2 foot plots of land. And we have these sensors that are deployed and literally modeling things like space weather, and that system is fully operational. And it's something that, like today, we can go and demonstrate anywhere in the United States that we can get to 10 centimeter level accuracy with GNSS GPS alone, and that's a really amazing capability. So that's one thing that we did that we're quite proud of. I would say the second is more of a company business milestone where it's very, very difficult to sell into car companies in their production cars. And we're very proud of the fact that we were able to get not one, but 2 production cars using our system. I know you'll ask, and unfortunately, I can't say yet who they are. It's very, very considered competitive information. I hope too soon. But it is really, as a small startup to have a big car company and not just one, but 2 of them, frankly, take a chance on us. Not only that the technology works, but that we'll be able to deliver it at scale. I think really just shows how impressed they were with the technology. And we're really happy to have that vote of confidence from our customers.
All right. So no follow-up questions allowed. Let's talk about the business. Tell us about your primary users. Oh, well, you kind of mentioned it's for the developers. Talk more about that, and how do you build awareness like among your users that Point One is the solution that's out there for them to use?
For sure. I mean, so when we started, we have a very broad goal. Like developers is a huge market, and so we had to be a little more specific in the beginning. And so we said we're going to focus in the automotive sector. And for the first, 3-4 years, that's really what we did. We said we're going to just do everything we can to get into car companies, and we were thankfully successful there. Now, what we've started to do is to expand that to a more generic use case. And what we're doing here is looking at people who are building the next generation of robotics. These are basically mobile platforms that need to know where they are. They may be doing all kinds of different things, whether it's, a car that's picking up a human, whether it's like a robotic lawnmower, whether it's a scooter. It's sort of something to us that we see all of those as developers that need precise location. So a lot of our current focus actually is how do we take the technology that we've now proven in automotive and bring it to all of these now emerging use cases. A lot of that has been solving for making it easy to adopt. And so that means partnering with these like chip companies that can go and make like a module that lets you use Point One by having a very simple part that you just add to your robot, and then all of a sudden you have 10 centimeter location. That's really actually what we're striving for. It's a plug and play, so to speak, and then making it so that when we look at adopting the solution, it's very easy to do. You don't need to have a PhD in all kinds of aerospace to use it. It's something that if you're a software developer, you should be able to get started and understand how it works and really scale from this very simple to use system. And I think this is the other side of Point One. Yes, we build a lot of hard algorithms and all the things that we talked about, but we also really try to focus on making it easy to use for developers, so that at the end of the day they don't have to go to Point One college or something. It's like they could just really start with easy documentation and have a solution working in a day, and that's the ultimate goal.
Talk about your business model. How's your business going to make money?
Our primary source of money is we charge a subscription for using our kind of precise location API. It's set up as per device per month, and depending on how many things you have, it's got different tiers. But we always try to make it affordable, even for people building one or two things, because at the end of the day, we definitely have some customers that have tens or hundreds of thousands of devices, and we can scale the pricing to make that work. But we want to also have the customers who are those new startups building the latest robotic something, or even developers that are just trying stuff out. We want them to be able to experience what we think is a pretty magical experience.
All right, let's move to some closing questions. To kind of recap the conversation we've had today, can you tell me like the one thing about Point One that in your eyes makes you stand out from the crowd?
Yeah, I'd say Point One is probably one of the only companies that is really taking a comprehensive view on how to solve location, specifically for things that move in the real world, these kind of robotic type of applications. And that is probably the most unique perspective that we have. And I think a lot of that, frankly, comes from my team's experience of actually building, full robotic systems. We bring that lens of like, what would we want? And we went and we built it, as opposed to others that kind of started from like, oh, we're, super excited about GPS, so let's go build that. Like, that's not our perspective. We're much more, how do we solve the problem?
Great answer. And yeah, I mean, it stands out to me too. It sounds like a really difficult problem to solve. I like the origin story, right? This was like a problem that a lot of robotics teams were having. So it seems like a big enough challenge for sure. Speaking of challenges, what are some challenges you face as a founder that keep you up at night?
Yeah, I mean, there's, I think, the usual things. Obviously, we want to make sure our products are successful in the market and all those kinds of things. And thankfully, like, I think we've had good success there. I think there's a lot of, especially with the pandemic and then some of the things that are happening in the world, there's a lot of uncertainty, chip shortages and, the terrible stuff that's happening in Ukraine, obviously. And I think that it's just something where those can have ripple effects, especially on like big customers, and from just the business's perspective, there's a lot of uncertainty there. I do think that we've seen some robustness against it in terms of like what our customers are doing, but it's still, I think it is a challenge for not just us, frankly. I think a lot of startups are in that kind of phase.
Before we get out of here, what's the best way for our listeners to reach you and Point One Navigation, maybe learn more?
Yeah. So, obviously we encourage people to check out our website at pointonenav.com. And we have all of our kind of products there. Like I did say, we will be announcing later this year a very easy and budget-friendly developer kit. So if you're building the next generation of robotics and you need to know where your device is, by all means, please do reach out, and we'd love to help.
Awesome. All right. Well, thank you so much. We're going to end our show. If you enjoyed it, please, subscribe wherever you listen to podcasts. Leave us a rating. Make sure it's 5 stars. Aaron, thank you for joining the show. We appreciate your time, your insights, and this is really exciting. So, best of luck. Awesome.
Well, thank you, Oleg. I really appreciate you having me. And yes, I hope to talk again soon.